Okay, good afternoon everyone. I would like today to speak about BCRA tiles. That's for British Ceramic Association, BCRA, British Ceramic, something like that. What these people do is they create, they build, they manufacture pieces of ceramics. And those pieces of ceramic are purchased by instrument manufacturer company, color measuring instrument manufacturing company like Minolta, like X-Rite, like there's not much players left. Other companies I can't think of. In Germany there's Teschkon, and in Italy there's Barbieri Instrument. There are a few players. Now, when we get our instruments, this is a certificate of performance, let's say for an i1 Pro instrument. So this is, assume I just purchased my instrument, I take this out of the box, and this is packed with the goodies that comes with my instrument. And what it means, what it reads, is there, it says inter-instrument agreement. In other words, what's the difference between the instruments? How different do they read? Presumably on the same color specimen. So what they say is an average of delta E 0.4. It's really small, and with a max of 1. And these are from X-Rite manufacturing standard at a temperature of 23 degrees Celsius. So I should put out my thermometer right now to see at what temperature the room is. And for single measurement mode on 12 BCRA tiles. 12 BCRA tiles. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, why do instrument manufacturers go through all this trouble to use something that's made by a British company to certify or use as some kind of reference for telling how good their instruments are, how little they vary, how good they're, how tight they're able to maintain them. They could use, this is a, home hardware ceramic. I think it's less than $1 a tile like that. But there's a lot of variation here. So it's not like the British tiles. This set, for instance, is an absolute reference. It is not an absolute reference. I discovered this the hard way. I thought these were absolute reference, and they're not. And but they are references nevertheless. So if I order my set today and you order your set tomorrow, you're not going to exactly get the same set. You'll get the same colors. There will be slight differences between the red tile that you get and the red tile and I get and the red tiles of everybody. What's important is to keep these things calibrated. Now, what does that mean by calibrating? Calibrated means that these tiles alone, like that, without any kind of calibration information, are worthless. So first thing one has to do is to send them to a lab to certify them. This is from the Institute of National Measurement Standards in Canada, and it's called a calibration report, and it explains their methodology. Essentially what they did is they say here which tile was measured. Let's say the yellow, the cyan, and the pink and the gray. They measured 4 tiles and they certify what these tiles were measuring under their reference instruments. So that kind of suggests that maybe if my instrument is reading anywhere close to what their instrument is reading, that's one source of verification. And once I'm satisfied what the tile is supposed to measure, and as a manufacturer I could use it to compare across instruments coming out the assembly line. Here's the same tile, here's the same tile, and they should all, you know, measure within the same kind of difference. Okay, so what I'm going to show you in this part of the tutorial or the video is how how to measure these tiles and how the results can be saved and compare. This, by the way, if you haven't seen, it's a white reference. It's a Mansell N56, I think. It's very, very, very white. It's very stable, but it's not to be taken as a reference white, for instance. So I'm going to put it away over here, and now I'm going to turn to the first tile. I hope you can see the tile in the box. I'm going to turn them sideways like that, so you better see them. So 1, 2, 3, and so on. So I'm going to pull the first tile out of the set. Of course, when I manipulate these tiles, I have to be very careful. You know, I know some people use cotton gloves, but I'm not that picky. And on the back of this tile you can see, if the focus is right, CCS series, and it says NRC, calibrated, with the date of calibration and the name of the technician and so on. So the tile is identified. So what the next thing I want to do is I'm going to slide them under this sort of a jig or template I created to be able to measure them always the same way. Problem is, if I measure them this way, take the instrument, when you place on the tile, you see how it could be I'm measuring from not consistently from times to times, and that could influence the measurement because the angle, the reflectance, everything counts. So what I did, in order to I'm going to check this, in order to minimize any possible problems, I created this, and all it is, it's a little square I cut in this foamy material. I slide it here under. See, in this space, it doesn't move. Then I flip the acetate on, and then I open my instrument, place on LEB, let's say, and of course I could calibrate before. That would always be a good idea. Actually, I could do that, calibrate it. So I'm going to go under the calibrate menu. Oop, that's the sound of my GTI viewing boot telling me that the length of time has elapsed enough that it has reached its temperature of operation. So now I should be able to look under this light for color matching, comparing my press sheet to my proof, blah blah blah. So I'm gonna go over here to calibration. Done. So press this down, hold the head, and the calibration is done. So I can now put away my calibration tile and work with this. Let's see. So now this is how I always measured, decided I always want to measure at an angle of 45 degrees the instrument, and I always try, if there's a point I can see, to place the head in the center of the tile. So I'm always measuring at the same place, you see. So now I'm going to go back up to color without moving the instrument around. Okay, so let me press this down now. Okay, I got a number of measurements. So what do I do with that measurements? It says 48 and so on and so on and so forth. So first thing I'm going to do, I'm going to move this over, and I'm going to bring my computer down. This is my computer. Hopefully you can see the screen a little bit. And now what I'm going to do, I'm going to make a copy of this sheet, and then call it copy. So I'm going to create a copy and then click OK over here. And now this one, I'm just going to call it 5/28, and I could put the date on it, and I have to record this. And this would be the instrument. So X write 5/28, and I can put the serial number, and I can put the date. You know, any details I can log with my measurements will be helpful in interpreting them. So the cyan. So today I have 48.68. I have minus 18.72. And I have, okay, what? I think it didn't like my, no, it didn't like my point, my period. So let me start this again. Minus 18.72. Good, it took it this time. And minus 34, wait a minute, 34.1. Now let's see how far I am from the ideal. The ideal is the measurement that was provided to me by the National Research Council. And on the National Research Council, I'll try if I can thumb through the cyan tile. And we're getting there in a second. This we don't need. Sorry for all, it's a little messy, but it's worth watching. So the cyan, you see I have the measurement here. 48.64 minus 18.90 and minus 34.56. So these are the numbers, the three numbers that are entered over here, and this is the actual measurements by the 528. So the difference here, it's calculated, with the spreadsheet. It comes out to 0.5 delta E. You know what? 0.5 delta E, that's not a whole lot. So I would tend to trust the measurement of this instrument when it says it's reading cyan. Now some people will argue that measuring ceramic is not like printed inks, but this is an argument that we hear constantly from instrument manufacturers, astonishingly. So let me put the cyan tile away over here very carefully, you know what, because I don't want to scratch it. Let's get the what's it called? It's called the purple, deep purple. Well, and I have to be careful how I lay them out inside the template here, because I don't want to, lay them out like that. I don't want to lay them out upside down. I have to lay them out always the same exact way. Otherwise, there's not going to be. I am diminishing. I'm weakening the repeatability of the measurement. So now let's take our instrument. Hopefully the battery is still there. And it says 9.0. So 9. Sorry, I'm going to turn over to the instrument so you can see a little bit better. 9.0 and then 16.76 and then minus 33.18. Okay, what does survey say? Like the old show. Now there's a bigger difference here. There's a bigger difference here. It's 1.72. Is that a very big difference? Well, that's a significant difference in the red for sure. From 16 to of 1. 1.72, some people could use another delta E matrix here and the number would come down, but I'm going to leave it as that for the sake of discussion. I'm going to measure one more and then I think I'll stop because you get the idea. The yellow tile. Here's the yellow tile. Yellow tile with its orientation. I put it here. I take the instrument and I think you need now to be on the table. So there's the head. I'm depressing it. Instrument is measuring away. So let's see what I've done. Now transferring this. I could have left the instrument connected to the spreadsheet, but I didn't want to do it. I wanted to show you manually how the process goes. Let me save before going further. So I need 82.1 and then 0.1 and then 82.86. That's, wow, huge difference. Huge difference. 87.51, that's a 5 delta E difference. Oh, it's going to be interesting. Okay, I'm back. I hope the sound is not too strong. I can see the level going up. I have to hold my microphone in my hand because when I leave it on, the three little legs that comes with it on my desk, it's picking up the hum from the computer, so that's not right. Okay, so this is the same spreadsheet that we were looking at 5 minutes ago, and these over here include all the measurements I've done with the 528. So you can see individually the differences. 535 4 for the yellow, 4 for the orange, 2 for the red, 0 for the pink. The gray is perfect, pale gray is perfect, difference gray is perfect, and a little bit difference in the green, but that's not the end of the world. So overall, on the 13 titles, we have 1.45 difference. It's not bad. You can imagine what it would be if these guys, especially these two guys, would have been lower. So there's a way that the measurements, these colors are measured at X-right, and they're calibrated into their instruments somehow, and the way that the National Research Center reference instrument measure these tiles. Let's just see, for the argument's sake, other instrument and older stuff I have here. This is a Barbieri, Aspecto LFP 8mm aperture. So 239, not bad. The yellow seems high as well. We could be comparing. I think we get a trend. 82 is the same as before, and versus 88. Let's see. Overall 2.85. By the way, if you're interested, you can email me and I'll send you the spreadsheet so you can study it. No problem. Be glad to. I1 Pro, this instrument. So this was done in February 2013. And what's the verdict? Oof. Again, same difference on the yellow and the orange. 1.04. The 528 was 1.45. Okay. The Specta I. This is made by Great Macbeth. Ooh, look at the difference between the Specta I and the National Research Center measurement. It's almost perfect. So there's something about X-Rite and those other instruments that just don't measure high enough in the yellow. It's very interesting, and look at that, 0.80 difference. I just breaks my heart to send my Spectra in for recertification because it doesn't quite read the same today, and I'll have to bite the bullet and try to read it for later on. But for now, no, because no money. That's the name of the game. So another set of reading, another pass with the Spectro LFP. This is the Spectro Lino. Oh, it's an old instrument, but it was freshly certified in April 2012 by X-Rite. And I'm sure I measured, I don't have the date at which I measured it. Too bad. But 0.84, that's a good one. Spectra I again, 1.08. This time it says it was measured May the 24th, 2011. This is a Minolta FD7. Was measured May the 24th, and look at the Minolta performance. Ew, look at that, 7.19. How could the Minolta measure so low on the yellow? It's like it's a trend almost, but I'm not going to comment further on that. And let's see, is there other? There's the Spectral Dance made by Teshcon. This one 0.78. See, not as huge a difference in the yellow as X-Rite. And this is an old Spectral Lino, 114. This is a Spectral Lino again, 1.74. And this is another Spectral Dance instrument, Spectra I, the same Spectra I. It does vary. Spectral Lino again, and then Spectra I. So you see overall the usefulness of this kind of analysis, because to me, if I'm able to trust my instrument, I can't say blindly, but to a large extent, then I'm confident in my measurements. And that's important, because when I see a number pop up on the screen or anywhere or on the instrument, then I know that I have to give it some reliability. I have to, it facilitates relying on the instrument. I'm going to stop right now because I think I spoke too much. If you have questions, please write to me. I'll be glad to help.